Good morning everyone, I am Annapurna, working as an assistant professor in the department of ECE at Institute of Aeronautical Engineering. Today we are going to study about oscilloscopes. What is the need of oscilloscopes, why we are using oscilloscope, and what are the different parameters or what are the different blocks that are present in cathode ray oscilloscopes. Cathode ray oscilloscope. This is mainly used to represent any waveform on the CRT screen. For example, if you are using any meter like ammeter, voltmeter or multimeter, we can get the output readings or output voltage readings like 10 volts or 100 volts or 10 milliamperes like that. But we cannot find out the waveform, or we cannot find out the how the waveform is varying with respect to time t. We cannot identify with the help of meters. So we are using this cathode ray oscilloscope to represent the output waveform, at the same time to measure how the output waveform varies continuously with respect to time t. That is the main advantage of cathode ray oscilloscope. In this cathode ray oscilloscope, the important parameter at the heart of the oscilloscope is cathode ray tube. We already discussed about that cathode ray tube. In that cathode ray tube, we have a screen, phosphorus screen. With the help of phosphorus screen, we can get the output waveform on CRT screen. In this cathode ray oscilloscope, we have different parameters like different blocks like CRT, vertical amplifier, delay line, horizontal amplifier, time-based generator, trigger circuit and power supply. These are the main components present in cathode ray oscilloscope. And coming to the operation of cathode ray oscilloscope, we have different blocks like CRT and triggering circuit, vertical amplifier, delay line, time-based generator and horizontal amplifier. These are the different blocks present in cathode ray oscilloscope. As we know that CRT is used to represent the output waveform on CRT screen. Along with this, we have vertical and horizontal deflection plates. As we know that vertical deflection plates help us to produce the waveform or to move the electron beam spot vertically from top to bottom or bottom to top. Similarly, horizontal deflection plates. These horizontal deflection plates help us to move the electron beam spot horizontally from left to right and right to left. This is about vertical and horizontal deflection system. Along with this, we have vertical amplifier. The main purpose of vertical amplifier is to amplify the input signal coming from the input section. Similarly, across the horizontal amplifier or along horizontal direction, we have horizontal amplifier. It is used to strengthen the signal in horizontal direction. Along with this, we have trigger circuit and time-based generator. This trigger circuit helps to produce the pulse or triggering. With the help of triggering circuit, the time-based generator generates the pulse or sweep signal. The time-based generator generates sweep signal, and horizontal amplifier will amplify the sweep signal coming from the time-based generator. And delay line. This delay line is mainly used to provide certain amount of delay. Along with this, we have high voltage supply and low voltage supply. High voltage supply is normally given to CRT, whereas low voltage supply is given to the amplifiers and sweep circuits. Coming to the operation, initially we are applying the input signal to the vertical amplifier. At the same time, we are applying the horizontal signal or external input signal to the horizontal amplifier also. In this vertical amplifier, it consists of different stages. Finally, with the help of all, the vertical amplifier will amplify the signal, that is, it strengthens the input signal and that is given to the delay line. At the same time, the input signal coming from the vertical amplifier is given to the triggering circuit. Whenever the output coming from vertical amplifier is given to the triggering circuit, this triggering circuit generates a pulse signal. With the help of pulse signal, the pulse signal is applied to time-based generator. This time-based generator now generates a sweep signal according to the pulse we have applied. According to the pulse signal we have applied, the time-based generator generates the sweep signal. So, if you apply the sweep signal, that consists of both on-time duration and off-time duration. During on-time duration, the external input will be taken by horizontal amplifier, whereas in the off-time duration, it won't take any input signal. So, during this time interval, the horizontal amplifier will take the input from the external and then amplify the signals. Now, after completion of amplification or strengthen the input signal along horizontal direction, the vertical amplifier with the help of delay line give the vertical signal to vertical deflection plates and horizontal signal to the horizontal deflection plates at a time. Here we have certain amount of delay. Why we need some delay means, after amplification in vertical direction, then only the signal is given to triggering circuit. With the help of that vertical input signal, the triggering circuit has to generate pulse, and then with that the time-based generator generates the sweep signal, and finally horizontal amplifier will amplify the signal. All these things will take certain time. During this time interval, the vertical signal coming from the vertical amplifier will take certain amount of delay. Finally, after completion of amplification in horizontal direction, both vertical amplifier and horizontal amplifier will give the signals to vertical and horizontal deflection plates at a time. Finally, with the help of vertical deflection plate, the electron beam spot moves vertically, and with the help of horizontal deflection plates, the electron beam spot moves horizontally, and finally it produces electron beam spot movement and it produces the waveform on CRT screen. Along with this, to run the CRO continuously, we need a power supply. We have two types of power supplies, high voltage supply and low voltage supply. Normally, the vertical and horizontal deflection plates which are present in the CRT, so that CRT requires high voltage power supply, whereas the amplifiers and sweep circuits all these requires low voltage supply. This is about cathode ray oscilloscope and how it generates the waveform on CRT screen. Now we will discuss about each and every block present in cathode ray oscilloscope. The first block is vertical amplifier. As we have discussed that the vertical amplifier produces the amplified signal on the output. And how it generates the amplified signal means, the vertical amplifier internally consists of two stages. One is input amplifier stage and second one is, before applying the input to the vertical amplifier, initially the input is given to the attenuator section. This attenuator will attenuate unwanted signal. Only the required amount of input signal is given to first stage. In this first stage, we have FET, that is followed by BJT. So what is the need of FET and BJT means? The FET we are using in this main amplifier, input amplifier section consists of high input impedance. So as it has high input impedance, the FET we are using, it has high input impedance. As it has high input impedance, it avoids the problems occur due to attenuator section. This FET is followed by BJT. The BJT we are using here provides the impedance matching, because the phase inverter section consists of low impedance, whereas FET consists of high input impedance. To match low and high input impedance, the FET is followed by BJT. Finally, the phase inverter. The input impedance across the FET and phase inverter, in the output coming from the FET and the input across the phase inverter can be balanced with the help of BJT. And then the phase inverter produces the output. The phase inverter, the name itself indicates that it produces the two outputs, and the two outputs are inverted with each other. The two inverted outputs are given to driver amplifier or main amplifier. In this section, we are using a push-pull amplifier. The two inverted outputs coming from the phase inverter is given to push-pull amplifier two sections. Whenever we apply the two outputs, one is normal output and another one is inverted output. The normal and inverted outputs coming from the phase inverter are given to the push-pull amplifier. Here the push-pull amplifier now consists of two signals. One is the direct signal and another one is inverted signal. Now this push-pull amplifier consists of driver amplifier and main amplifier. Now the driver amplifier is mainly used to drive whatever the output coming from the phase inverter that is given to the next stage. In that stage we have a push-pull configuration. So it will take the two inputs coming from the phase inverter, and with the help of this push-pull amplifier present across the main amplified section, we can avoid the noise or hum present in the signal or any distortion. All these can be overcome with the help of push-pull amplifier present in this main amplifier section. Finally, after removing this hum or noise or distortion present in the input signal, then the two signals are given to the two sections of vertical amplifier. As we know that in CRT, we have one set of vertical amplifiers and one set of horizontal amplifiers. The one set of vertical amplifiers has the input coming from the push-pull amplifier. This is about how the vertical amplifier amplify the input signal that is present in cathode ray oscilloscope. Once again, if you observe the vertical amplifier section, it consists of input attenuator, FET input amplifier and main amplifier. For example, initially if you are applying any input signal, the input consists of any noise that can be avoided with the help of input attenuator. After that, the input signal is given to FET. Why we need FET here means the FET having high input impedance. Due to its high input impedance, the problems occur due to the attenuator can be avoided, and then that is given to the phase inverter section. And in between the output coming from the FET and phase inverter, we are using a BJT. The main purpose of BJT is it provides the input impedance matching between phase inverter and the output coming from the FET amplifier. Why? Because the phase inverter consists of low impedance, whereas the FET output consists of high impedance. To balance these two, we need an impedance matching. That impedance matching can be done with the help of BJT. Then the output is obtained from the phase inverter. Now the output coming from the phase inverter has two sections. One is normal output and another one is inverted output. The two outputs coming from the phase inverter are now given to the main amplifier. In this main amplifier, we have a driver amplifier and then we have push-pull amplifier. The driver amplifier is mainly used to drive whatever the input coming to the driver amplifier that is given to the next stage. In that next stage, we have push-pull configuration. So, in this push-pull configuration, the output coming from the phase inverter is given to push-pull amplifier. Why? Because the push-pull amplifier is used mainly to avoid the noise or hum or any distortion present in the section can be removed with the help of push-pull amplifier. At the same time, it produces the output. So, the push-pull amplifier is connected to a vertical amplifier. Vertical deflection plates. The CRT consists of two sections of vertical deflection plates. The two sections of vertical deflection plates are connected to push-pull amplifier. Another thing why we need FET or FET means in this vertical amplifier, the FET provides constant bandwidth or constant gain. As the gain is constant, as the if you're using a FET amplifier in vertical amplifier section, it provides a constant gain. As the gain is constant, it is very convenient to design any circuit because as the bandwidth or gain, both the parameters are maintained as constant. To design amplifier section, it is very convenient. So, to provide constant gain and constant bandwidth, we require FET amplifiers. At the same time, it produces maximum stability in the circuits. That's why we need FET amplifiers in vertical amplifier states. That's why we are using FET amplifier in the starting section and then move with main amplifier, which consists of push-pull amplifier to avoid the noise or hum present in the output. And the next section is sweep signal generator or time-based generator. See here, the first section is the vertical amplifier. Already we have discussed about this vertical amplifier, and next one is time-based generator. Now we will discuss about this time-based generator or sweep signal generator. This is the continuous time-based generator or continuous sweep signal generator circuit diagram, which consists of FET and a resistance RT. This is variable resistance and capacitance CT, and we have two resistances R1 and R2. The supply voltage we are providing is VBB. This is the circuit diagram and this is output waveform. As we know that initially the FET is present in off state. As it is in the off state, we are providing the supply voltage. As long as the supply voltage is given to the circuit, the capacitor starts charging. The capacitor starts charging through the resistance RT. Whenever the capacitor is fully charged with the help of supply voltage VBB, the emitter voltage also rises. As the emitter voltage rises, that FET is going to on state. When the FET is present in the on state, whenever the FET is present in the on state, it starts discharging through the capacitor CT, so that the capacitor starts discharging and it reaches to a minimum value. Whenever it reaches to the minimum value, again through the supply, whenever it reaches to the minimum value, it is turned into off state. As it is turned into off state, again through the supply voltage, capacitor starts charging, and whenever it reaches to the maximum value or peak value, FET is going to on, and then through the lowest charging discharging part, again it start discharging like this. Like this, the capacitor starts charging and discharging, which produces the sweep signal in the output section. If you observe here, initially the circuit is, the FET is present in the off state, so that the output voltage is 0. As long as we provide the supply voltage, even though FET is in the off state, through the resistance RC, if you provide the supply voltage, the capacitor CT starts charging. The capacitor CT charges and it reaches to a maximum value. Whenever it reaches to the maximum value, then as long as capacitor charges and it reaches to the maximum value, the emitter voltage also maximum, so that the FET is turned into on state. As it is turned into on state, the capacitor starts discharging and it reaches to a minimum value. Whenever it reaches to the minimum value, again UJT is turned into off state. UJT is turned into off state. Again, it starts charging and discharging. Like this, due to the capacitor, it starts charging and discharging and produces the sweep time and retrace period. Here, The time required for the capacitor to charge is called as sweep time, whereas the time required for the capacitor to discharge is called as retrace period. So within the sweep circuit, we have trace interval and retrace interval, and this is called as peak voltage, and this is called as VBB. As it reaches to the peak voltage, the charging of the capacitor reaches to the peak value, then only UJT is turned into on state. If UJT is turned into on state, the capacitor start discharging. So with this help of a capacitor, it produces charging and discharging intervals. Due to this, it generates continuous sweep circuits. So that is called as continuous generator or time-based generator. The main advantage of continuous or time-based generator is it produces continuous sweeps with irrespective of input signal. The sweep signal generates the continuous sweeps, so that whenever the input signal having constant amplitude and frequency, we are using this time-based generator. These are the main blocks present in cathode ray oscilloscope. As we have already discussed that the cathode ray oscilloscope mainly consists of vertical amplifier and time-based generator. Now we have discussed about the vertical amplifier. The vertical amplifier is mainly used to provide the amplification and finally strengthen the input signal, and that is given to one set of vertical deflection plates. And next one is sweep generator or time-based generator. With the help of UJT, we are going to get the sweep signals. Initially, UJT is present in the off state. Through the VBB, through the resistance RC, the capacitor starts charging. As it reaches to the maximum value, UJT turned into on state, and then capacitor starts discharging through its lowest discharging path. And again, whenever it reaches to the minimum value, through resistance RC, capacitor starts charging and it reaches to the maximum value. Finally, it produces the charging and discharging intervals with the help of a sweep circuit or time-based generator. And the textbook we are using is Kalsi. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.